that I'm underprepared for this after looking at what the other speakers have presented, because I wasn't aware of the audience that are coming here. So apologies beforehand. And also, secondly, my role at Google is to help customers to get on with GenAI and solve their business problems. So what I'm going to do right now with you guys is not going to cater to folks who are already well versed with how to deploy stuff, etc. We'll help you to help the people who are in the beginning of using LLMs and use GCP as a platform to get started and see, hey, how can I use it on GCP? I want to deploy Gemma models or Llama models or Falcon or anything. So we'll see how easy it is to deploy GCP and nothing more complex than that. So I bought the graph from complexity. So Dr. I forgot his name, Manish, and made it down here. So I'll carry it to the folks who are new to the LLMs.
No, easier is better.
Yeah. Again, as I said, I'm underprepared. No, I'm not doing that. I don't do that because I have a customer facing role in Google, so I know when customers come, I never do that. I just say what's it there. You have to be clear with that thing. All right. Can somebody help with this? We have a Chromebooks, so it's a different thing for me. Yeah, problems with using different OSs. Alright, so everybody's aware of, you got your Kubernetes clusters. That's kind of pretty easy for everybody to have. Now, people who haven't used or deployed any of the LLM till now, can you raise your hands? Not tried them, not deployed them. Cool. So how do we start? Where do we start? Even though I'm talking about Google Cloud Platform as such, the frameworks that I'm going to talk about is nothing specifically related to Google Cloud or proprietary to us. It can be your own thing. Kubernetes is not something Google make it commercialize or something like that. So what you do is simply create a cluster as normally you do in Kubernetes, right? So you just have to make your own clusters. Once you do, what else you need? Just put some CPUs, like Meg was mentioning. You and Dr. Manish was telling, everything is not done on GPUs. You need some sort of a CPU there which does your basic work, and the main part of it where you have to send your data or do the inferencing or serving your LLMs, that part to your GPUs. Now how do we start with it? Now add a particular pool, default pools with your basic CPU testings. Nothing more than that. You just add your clusters and your default pools with how many nodes you want. I'll keep as small as possible because, as I said, what we're going to typically do is create a cluster with just CPU and add an additional pool with GPUs in it. Now, once I create my cluster, I'm not going to do that right now because it takes too much time to spin up everything. I have another one which is already ready. That comes with your node pools. Now, how do you add an accelerator? Now, as we know, GPUs come up, for your Kubernetes cluster, if you want to add a node pool with a particular configuration, like Meg was talking about A100s, H100s, etc., you just have to go ahead and add a pool to it. Go ahead and start having what kind of GPUs you want to have. Even we have a Google proprietary GPUs if you want to. But again, as I said, that's something you should be available to use. So we go ahead and see which kind of machines that you want. So we provide, like the other day, you might have seen the screen that Dr. Manish was showing regarding who they are partnered with. Even Google Cloud is partnered there, where you can see store optimized up with GPUs as well. Now, the most important question that customers ask me, sitting in the place where solutions consulting or architecting kind of thing is, Moksh, cost. Where do we start? Where do I want to try this stuff? Like, A100s are beasts. Even though they're old like Mr. Makers mentioned, they are beasts, but they'll give you significant amount of costs. Now, what we do right now to help our customers or startups to go ahead and start their LLM models or worry about how to tune it, is it working good, should I have control of my infrastructure, we suggest them use something like L-Force. That's good enough for a medium scale models that we have. Like the one we are talking today right now is again Gemma models, because I come from Google, so I'm going to stick with that one only. So Gemma 7 billion parameters is quite less compared to what other speakers are talking about, 70 billion or 130 billion. For 7 billion, the L4s are quite good enough for serving and seeing the performances, etc. Just deploy that and try it out, see how it works. Then we can talk about low ranking adaptation or Q low ranking adaptation for tuning it in further down the line. So once you add your pools, now you have started the base part of it. Like you created your cluster, added your pools. The next part is getting the model from Hugging Face interface or somewhere where the models are, getting them, deploying on it. So the part, how does it work? That's where your manifest file works. So basically you have your YAML files to deploy stuff in GKE, right? That's something not new, that's been there for years. Similarly, you can create your own image for your Docker, or you can use what Google provides for you from their openly available image, where you have, like Mr. Mike was talking about, here we use the one that I'm deploying on the screen is specifically on LLM framework. Like you say, you want to create a separate image for TensorLM, TensorRT LLM, what Mr. Mike was mentioning, you can do that, or TGI interface from Hugging Face, you can do that. You can create whatever you want, but if you are a beginner and want to try it out, you can utilize something that pre-built images that are available on Google Cloud public buckets. Go ahead, deploy them. Once you deploy them, it'll take a few minutes to come up, from Hugging Face or somewhere, where the model will be pulled out, start running on your LM after a few minutes or something. Once it's up and running, that's it. That's where you start you get to see, okay, I'm seeing Gemini or ChatGPT, everything on browser, go to the link and see. But this one is something you own, something like you put on your own cluster, you see it's running, that's where it is. Now let me just go ahead and show you some things. I'll just forward it to one of my board. All right. So I have a ready-made prompt already made. So, like we just talked about, it's easy to start with. The granularity of it, as I said, I'm underprepared. Speakers have already spoken about the very detailed granularity about how to choose a specific framework. When to choose VLLM, when to choose TGI, when to choose NVIDIA's own framework to use your things. That all depends on the next layer of it. But when you start to look at how these things are working, how can we start and play with this is where you go. Now you can also start giving it far more things. Like let's say, if you want to give an interface to something like that, you can also use some activities like using Gradio or something. How many of you used Gradio for a chat interface or something like that? Quite easy, right? Point the same thing, deploy a Gradio as well onto your this piece. Let me just put it on board. Alright, let's see if this works, if I deploy it right. So again, out of the box, there's nothing that you have to do. That's the base fun of this part. Yes, you can customize it, you can build your own interface to play with, you can build your own web application as a front end to your serving endpoint. But for us to just see how we start, how we use it, that's where you go ahead and play with this. You go, let's say, anything, right? Let me just write. Let's see what it does. Not bad. Alright. So this is where you started, right? Where you go have to play with this and all those. But extension to this, if I come the next time, then we'll talk about in detail of how can we tune this further, like using low-ranking adaptation techniques or quantized low-ranking adaptation techniques on your own. Now, one other thing that customers ask, Moksh, stop saying all this nonsense, like, why do you want to install all this? Too much cost, too much GCP. GPUs are costly. We have to maintain, we need machinery engineers who have to do all this work for us. Why do I do it? OpenAI gives me APIs, GCP gives me APIs, Microsoft gives me APIs. I just integrate and build my apps, right? But there are things that you have to always take care of. Like, I come across customers who talk to me that, too much cost. Like we said, there's always a trade-off. What you're trying to solve, who are your audience, what is your market, those kind of details to solve your problem. That's one aspect that you always look at. Then expertise. Expertise are, again, if you're building your own LLM model to have whole control on it, like having throughput or having specific areas of how do you tune it properly. Like normally what GCP provides for other models like our base models like Gemini or our existing Palm models is you create a adaptive layer on the existing base model. So that's still an opaque layer that you can't see what's happening behind the scenes. Even though you say that I'm taking the base model and doing it, it might not be happening on your infrastructure. It's just tuning somewhere. But here you have to know that. And the workload part of it, the consistency and demand. You always know that if you're outsourcing or depending on some commercialized APIs, you can't always say that that's going to be up and running. They give you SLA, fine. They say that our things are 99.4 nines or 5 nines or 6 nines. But is it that critical that your application has to be far more better than that? Should we have to run our own LLM with much better infrastructure, looking at our recoverability or our things? That's why you decide, should we run this or not? Then also sensitivity, like when you start deploying in various places, the APIs might not be available, like some APIs might not be in India, some are not there specifically in EU, where you have your compliance requirements where you don't want to send your data to an input request or a prompt to a specific API, which you don't know, it's processing that sensitive data somewhere else. Now that's going to be another pain area for enterprises or businesses in the medical industry or in companies who are following GDPR, etc., where is my data going? Like if you spin up your own environment in your own required region, you get your own control over the sensitivity part too, and time to market. Now, if you want to go ahead and build a tool and get on board and use stuff, using existing LLM endpoints are quite easy. But if you want to do it differently, like your own custom tuning, tune the parameters in my own way, those kind of things, you go with your own infrastructure. Next thing is, how is this changing everyday life and way to use it? The reason I put up this is not because Google has had its own products with LLM integrated capabilities, to give you an idea of how you can use and pick up a small problem that you see in day-to-day life. Like tomorrow you see something, hey, India is a big country, we have tier 2 cities, villages, where you might see you want to apply same logic, you want to try it out, an idea or a startup or something that can solve that particular problem. So if you see some products that we have in GCP that helps today's world is contact center AI is something which helps you in customer service, like helping people automate your conversation with the customers and customer support. How did this improvise with LLM? Earlier, when you used to talk to bots on your any application or your banking applications or anything, the responses were quite kind of prescribed. Like it's not like specifically human-like talk or understanding your nuances of how you're asking the question, understanding your details. Now, LLM has changed that. It has improved the way it communicates. I've seen it implemented with my own hands in various customers where they were like, wow, this has become much better. Next, the customer representative sitting or agent who is talking, they want details of existing cases. Like let's say they have cases on same issue earlier. Now, it's very easy for them to summarize all those cases and give them an answer. Next is with document AI. OCR been there for a long time. Like you've been extracting text from your PDFs or anywhere on your images, everything there, great. But now with LLM, let's say the other day we were talking about some use case with a medical company or somewhere where we want to summarize thousands of documents. Now document AI earlier used to only extract data in key value pairs or do a form parser, everything, parse everything out, give you the text, do whatever you want after that. With LLMs, instead of going through all those data, sending the whole text to everything to the LLM and saying, hey, I don't want all the text. Get me the few part of it which I need for my work, improvise it, give them back. We'll store this and make whatever we want. So improvising your existing products, better than better. Next is your discovery AI, your product recommendations. How do you recommend your products, your business, retail industries? Again, another place where you're doing it. Healthcare AI, specifically on designed, integrated with particular format of data that it's stored, they have their own formatting, etc. Now, other two things that you have in enterprise grade is Vertex AI search and conversation. Now, like we talk about how do you talk to your documents? Like you have your own documents, they are being indexed in the behind the scenes. Now you want to talk to it, ask questions on your thousands and thousands of documents or PDFs, etc. Or even on JSON files. But the main thing, like you do a Google search, you can utilize similar things on Vertex search as well, which is empowered with LLM capabilities that it finds all its references in multiple documents, similar approach. Find wherever the particular words are there, pick all the documents, pick the texts, send it to LLM, summarize it, improve the search capabilities of your intra-site or any other application. AI. Now, I'm not sure if you have noticed the part where when I was using this particular part, now I forgot some commands, let's say. Now, cloud developers or consultants who have been in cloud for some long time, our way of doing is, I forgot my command line thing, like Cloud, what are the next parts? I don't know, go search for this. I want to build a whole part of a script that says, deploys this particular pipeline. Again, go and search. Because it's not needed these days to memorize everything in the top of our head. Because we can't do it. Every cloud has their own commands, every cloud has their own utilities. Who will do all that? All you need to know is there is a commands exist for this. Now, let's say if I just ask this thing into GeoIT, if I just say create gcloud command to create cluster, GKE cluster with 2 nodes in US Central 1. Sorry. Anyway, let's see. Now, if I'm being there doing a lot of years of deployment using gcloud commands or any other utilities, by looking at it, I know that it might be something wrong a bit, but it helps me. I can just copy paste it, edit it, run it. So, the intention or the motive to show these tools how they change your efficiency as a developer or a builder solving customer problems is that there is no end to it. You can think of any idea, deploy your own model, tune it to a specific tasks and try to use those models to solve a particular problem. Maybe you can generate a startup out of it, solve the business problems, become a tomorrow's billionaire, whatever it is. So there is no end to your problems. Go ahead, try those details. If you have any questions on how to solve problems with GCP, you can come to me. Any questions on this? Yeah, go ahead.